Hey, pre-calculus. In this video, we're going to be talking about section 2.2. This is our second day. We're going to be graphing and understanding polynomial equations. So one thing you have to make sure you understand about a polynomial is, or its equation at least. So a polynomial with a degree of n has at most n real zeros. So a quadratic, right, has a degree of 2, so it has at most 2 real zeros, which makes sense. I don't want to end that sentence though. We'll say and n minus 1 turning points. So quadratic has 2 minus 1 turning points, so 1 turning point, and that also makes sense. Alright, now we need to talk about roots. So there are single roots. So if we had, I'm going to do a little sketch. So single root looks like so these are the roots. X values of the x-intercepts. And single roots occur when the exponent of factor is equal to 1. So if the exponent has a factor equal to 1, you know it's going to look like it's going to go straight through. So an example would be y equals x plus 1 times x minus 3 times x minus 7. Each of these, so this makes a polynomial, it would be a cubic, because I would, if I FOILed this all out, I'd have an x cubed. But each one of these has an exponent of 1. So at these 3 roots, we would go through straight. Okay, the next one is double. So that could look like this. So this and this are both doubles. That happens when your exponent is even. And it bounces off the axis, if you will. So an example would be if you had x plus 1 squared times x minus 3 squared times 2x plus 1 to the 6th. So each one of these is just going to bounce off. This would have a degree of 6, 7, 8, 9, 10, and a leading coefficient of 2 to the 6th, so 12. Okay, so then the last one is triple. This is when your exponent is odd. Students have the most difficulty drawing this one. Hopefully you guys are okay at it since you did this last year in Algebra 2. If not, practice is what you're going to need. You're just going to want to literally practice trying it over and over again. So if it were going up, it's when it flattens out like a cubic. So these are roots of an odd or triple. And so your exponent is odd, of course, with the exception of 1, because that's its own thing. It kind of flattens out. As it goes through the axis. And an example with odd roots would be like y equals x plus 1 cubed times x to the 5th times x minus 5 to the 9th. So all of these would flatten out as they go through the axis. Alright, so let's do an example putting all of this together and showing you how much work you need to show for a problem that's graphing. So graph f of x equals x plus 3 squared times x minus 1 cubed times 2x. Alright, so we need to determine where our roots are going to be. So you need to set this equal to 0, which everyone does need to show. And then we're going to use the zero product property. So even though this has a multiplicity of 2, this has a multiplicity of 3, and this has a multiplicity of 1, we can ignore that and just set each one equal to 0 on its own. So zero product property, and we're going to solve for each root. So this will be -3, +1, and 0. Then you can either do this in your head, or I like to write it down, and I recommend writing it down. So because this is squared, this is even. It's kind of like a little cheat sheet. It's going to bounce off at this point. Here, it's odd. So we're going to flatten out at this root. And then here it's single, right? The exponent is single. So it's going to go straight through. Okay, so that's part of it. Now we want to do the leading term test because we need to know what the end behavior is going to be like. So the degree is 6. The leading coefficient, right? So 3, 4, 5, 6, because if I expanded this and then FOILed everything out. The leading coefficient, so we would have 1 squared, so that's just 1 times 1 cubed, which is 1 times 2, so that's going to be 2. So I know that this is even and positive, so that's going to be from the left, it'll be opening, coming down, and then it'll end going up. And I don't have to write the end behavior in limit notation, this is just purely to help me graph. So the possible real zeros, because I could ask that, so let's take notes. The possible real zeros is the same as the degrees, so there's 6 possible zeros. And the possible turning points, I'm just going to say TP, would be 6 minus 1, so 5. Alright, so now let's make our coordinate plane. I'm going to go, so we're not going to care about the y values. So I'm not even going to label my scale. We don't care, but we do care about the x's. So that's the only part that's going to be accurate here. I'm going to do 1, 2, 3. So my scale is technically 1/2. Remember, if you change your scale, you need to label your min and your max. It also just helps labeling your min and your max, especially during remote, since you're uploading everything. Alright, so first thing I would do is plot your roots, so -3, +1, and 0. Now we have to make sure we start in the right area, so we're going to start in the top left coming down, and we need to make sure we intersect the correct way, so we're going to bounce off. So I'm going to come down, bounce off my first turning point. I need to go through over here, and I need to go straight through. And then I need to flatten out over here. It's a tight squeeze, so I'm going to turn, flatten out, and end going up. So then go back and double check. So our end behavior is correct, right? We're starting and ending in the right spot. We're bouncing off, going straight through and flattening out in the right spots. The height of these turning points doesn't matter. You want to just do whatever's going to help you get a nice looking graph. And if you mess up, please erase and redo it or fix your mistake. And then practice is what's going to make perfect, so definitely want to do some practice with this.